Hello, I'm Vytas Sunspiral, one of the robotics researchers here, and I'm going to tell you and show you guys a robot that I guarantee is unlike any other robot you've ever seen. It is a tensegrity-based robot. We're exploring really future technologies, future approaches to robots that are different than the traditional sort of rigid form structures that you think of when you think of a robot, and really pulling a lot of inspiration from biology and how nature works, where everything is a bit flexible, everything is a bit compliant and adaptable, and our bodies work through the tensile network of our muscles and tendons and cables that are in our physiology. So we're taking those sources of inspiration and looking at how can we build very future-looking robots for solar system exploration and planetary exploration. We have some support from the NASA Innovative Advanced Concepts program that really looks at what technologies are going to revolutionize space exploration like 20 years out from now. And so you'll see this sort of spherical bundle of cables and rods over there. That's our Superball bot, and that is designed to be a multi-function planetary exploration robot that can land on the surface of another planet a lot like it was its own airbag. It can absorb the impact of landing, let's say if we're going to Titan, and then once landed, it can roll and move on the surface of that planet too. So you've combined these different functions into one system, and that saves a lot of mass and increases our ability to do science on those planets. It also means you have a robot now that was able to safely land from orbit all on its own. So if you want to go up to the edge of a skylight or an entry to a cave or over a cliff, you might be able to do that now. You might just say, okay, we'll jump off that cliff and see what happens. It's a very different approach to robotics to have that level of resilience and robustness in your systems. So that's the initial inspiration. These things are very counterintuitive to how everything else we've done with robotics for the last 30, 40 years. So there's a lot of new research being done in how to control them, using ideas from neuroscience and evolutionary algorithms and machine learning to figure out how do these things actually function when we build robots on this principle. And you also see over there we're exploring things like flexible spines based off of this basic architecture, this idea of a flexible tensile network, because really at the heart of it, that's where all motion in mammals come from, is from the spine, from the core. And yet you see that all of our robots so far that have been built in the world either have wheels or if they have arms and legs, they put lots of effort into the arms and legs and then just bolt it to a rigid torso and call that a robot. And that is, it's a good place to start. That's how anyone, who picks up a tennis racket begins. But really to become proficient in movement in the world, you need that flexible, adaptable core. And so we're really trying to make some progress on that too. So that's I think the fourth booth over there, and you'll tell because it's a very strange looking robot.